Hello friends, welcome back to the bench. Now, for the past few weeks I've been working on this software for this machine. I'm working on the second version, or the version Pro. You may have used version 1.4. The 1.5 hasn't been released yet, but what I do while I'm working on it, I connect it to the machine and I test it, right? Normal. So what I discovered is gonna probably shock you. Or maybe not, maybe it was expected. Now before we get to it, a quick announcement. Today is the 12th of January, Sunday. No packages are being sent or delivered to my shop, and that will remain for a few more days because Atlanta has been frozen. This is not something that Atlanta is equipped to deal with, so anytime that happens, we are completely shut down. All the post offices, all the UPS stores, everything is closed. It looks beautiful. It's cold. I mean, I'm from Poland, so it's not a big deal for me. I also have Subaru Outback all-wheel drive, so it's not a problem. It doesn't really stop me from doing my usual business, but I get no packages. I've had some inquiries from you guys, whereas like I sent the package a few days ago. Did you receive it? No, I didn't receive it, and I have a whole bunch of other packages that I know are waiting, are out for delivery, but are not going to be delivered, and I don't know how long. It looks like it might be even a week that we see the delay. So, well, blame climate change, government, whoever you want, but the bottom line is the post office won't deliver anything, and the UPS either, and I'm guessing FedEx neither. So our IR6500 has a thermocouple installed over here, right? That we attach to the board, but you can buy several of these as long as it's the same spec. This needs to be K-type, and I don't remember. There's few types of K-type, depending on what temperature range you want to work on. This one is for I think 400 or 600 degrees, something like that. Typically on this machine you don't need temperatures higher than 300 degrees, and even that is not quite needed. So it's most likely the 400 degree thermocouple. Now, thermocouples and thermistors are different. It's a different technology. This is a 10K thermistor. Right, as you can see, there's no plus minus on this one because it works like a resistor. The resistance of it drops as it heats up. The main difference, other than no polarity, because it's a resistor after all, the main difference is the relation between the temperature and resistance. In case of thermistor, it is linear. So you can pretty much draw a line, and depending on the temperature, you can easily calculate what the resistance is, and vice versa, because obviously you're reading resistance from it, and based on that resistance you deduce what the temperature is. They can be very accurate within small windows, so say maybe negative 20 degrees Celsius to positive 45, maybe 50 degrees Celsius, and that's pretty much what you get from thermistors. So obviously that's not going to be useful for the machines that heat up to 300 or 400 degrees Celsius. Thermocouple, on the other hand, is kind of like a battery. So as it heats up, it's called thermocouple because it's literally a two metals fused together, and as they heat up, they produce electric potential. So even a little bit of current flow, but basically it's only the voltage that we read on these. So the higher the temperature, the higher the voltage. For that reason, every thermocouple comes with polarity. You have little plus and minus over here. And those little pegs over here, those little pins, are different thickness, so you can't put it in the other way. It only goes one way into the socket. The other significant difference is that the voltage is not linear like the thermistor is. The voltage goes slightly, it goes relatively steep to a certain temperature, then remains slightly flat, and then goes high on higher temperatures. Again, it goes steep. So this is completely different calculation that you do if you want to convert the voltage from thermocouple to the temperature. To read those thermocouples, you can use one of these cheap Chinese thermocouple thermometers. It's basically converter. It converts from that tiny voltage coming from the thermocouple into the temperature that it will display, right? So we can connect a thermocouple to this one, and it's 26 degrees, which is pretty accurate. And if we hold it, the temperature goes down, and it should be roughly around 30. It should be roughly around 36, because that's the body temperature, but we can see it's pretty accurate. The other type of thermocouple is this one. You can buy them at different lengths, right? And these are designed to just stick in somewhere, right? The very tip of the thermocouple is what reads the temperature, right? And again, it should go roughly to 30 some degrees. 36 would be very accurate, but we would have to probably stick it into our ear or something like that to actually read the temperature. But as you can see, it's pretty accurate, this thermocouple, and the other one as well. So what if we want to use this thermocouple on this machine? Well, it should be easy, right? For this, let's use our unfinished version of the software, and let's test this one. So again, if I touch it, I should see about 33 degrees, but I'm seeing 23, 24, 24, and no higher. So this is not calibrated, right? It's a lot lower, but you know, it's supposed to work in higher temperatures, so we could ignore that. But let's turn on the device so it heats up, and let's put the thermocouple on the heater. Okay, it's saying the maximum temperature is about 34, but I'm touching that heater and it's burning my fingers, so the temperature is closer to maybe 60 degrees. So we are off by about 20 degrees at least, right? So let's replace the thermocouple, and let's try this one first. So again, we're gonna use plus and minus as they go, and let's put it on the heater, and what happens, the temperature is going in the other direction. Let's start it so we can get some decent temperature. And as you can see, the temperature is now at negative 85 degrees. Now what does it tell us? Well, obviously thermocouple is inserted the wrong way. The polarity is wrong. It's producing negative voltage as far as the machine is concerned, and it's being read as negative temperature or lower temperature. So this should be probably around 120 degrees positive, while it is negative 120. Now, as I told you, there's no way to put the thermocouple the other way because the size of the pins are different. So it's got to be inserted this way. As you can see, my software doesn't even support something like that, so we went way outside of the canvas that it's supposed to be drawing on, because I didn't think that we would do negative temperature. Obviously, why would you? Now, just for curiosity's sake, let's connect the other thermocouple. and see what this one does. Same thing, going down. So what's going on here? How come I cannot replace the thermocouple? Well, what happened is very curious. So this thermocouple came with the machine, right? And it has positive negative printed on it, but it has been wired the wrong way. So whoever was testing this machine connected the thermocouple and tested it and noticed that the machine that the temperature is going to the negative instead of positive. So instead of checking whether this has been wired the wrong way, they just flipped the wires in the machine on that side, so the positive is connected to negative and negative connected to positive. That's why it works with this thermocouple, but it will not work with any other thermocouple because these are wired correctly. You know, ever since I received this machine, there were plenty of subtle issues, meaning I had to loosen all the nuts so the machine is aligned, so it actually moves up and down. It was dropping. A lot of very subtle issues, but it definitely tells you that the quality control is very minimum on these. And well, you could say that at least they caught the issue with the thermocouple and they corrected it, so at least the machine didn't come to me showing negative temperatures instead of positive temperatures, so that's good. But you can see that there's pretty much no senior oversight of the implementation of these machines. So someone designed it, and I must say this is definitely designed and produced better than what I would have produced, DIY machine. We'll see what we produce once we start actual work on the hardware for our open source preheater or rework station. We'll see what we'll come up with, but this is done very nicely. It is pretty maintainable. You have only few screws here and there. It is designed well. It has the fan in the back to remove the heat from the chassis. It is pretty stable. It is done well. So the design is good, but the execution is horrible. I am worried what I'm gonna find once I open this and see the wiring on the other side. Because if this slipped through, then what else slipped through? And finally, maybe just a quick presentation of the new software. This is Pro version. Now, this will do pretty much the same thing that the free version does, but it's just designed for more of a professional work. So as you can see, the profiles can be named. You can add as many steps as you want. So we're not limited by the 8 steps that the machine comes with. You can define addresses for both heaters, and you can switch protocols. So at the moment we only use LA808, which is for PC410 controller, but we're gonna have the second protocol for the rework station that we're working on. And also you get the nice graph, and obviously you can just switch the profile. We can disable whatever you don't want to see, right? We can see how power went up when we turned on the machine, but whatever you're not interested in, you can just disable and just see perhaps the temperature alone. Now this, as you can see, this is not by design. It should never happen. The temperature only should go up, not go down. But as you can see, it also does work. You also don't need to guess the COM ports. The COM ports are detected automatically, and only those connected COM ports can be selected. it's a lot easier to work with the sheet over here instead of separate boxes and stuff, right? So we can do cool down to 100 degrees, dwell for 10 seconds, or we can set the bed temperature for the preheating. Bed temperature we wanted 145, and we want to wait for the bed, right? And we can update that, which I'm not gonna do right now. So the work is continuing on the software, and that will allow us to use this machine in a more professional manner. But first we need to resolve the problem of the thermocouple. Literally not something that I expected, but I probably should have. So in conclusion, the temperatures that you see on my screen, it could be off by 20, maybe 30 degrees. For that specific reason, I have the second thermometer that I connect to the back of the board. It usually shows lower temperature, but it's not connected to the board the same way as this one is, and it is usually in the back of the socket. So probably my temperatures are actually lower than the ones that are being seen. Not sure yet, but I'll connect the third thermometer. So I have 3 readings and estimate how much off is the thermocouple. The Pro version of the software will come with the ability to calibrate the thermocouple, so you'll be able to kind of shift the bed or shift the 0 on the scale depending on how much off your thermocouple is. So now you see why you should never replicate the numbers from someone else's machine and expect a perfect job to be done, the perfect results. It's a lot better to just start testing your machine, because every machine is going to be slightly different, unfortunately. And with these machines, as we can see, the build quality or the quality assurance is pretty low, so you have to expect that not only you're gonna have to mod the machine to be more productive, to get better results, but sometimes you're gonna have to mod the machine so it just works correctly. I don't know if there isn't a impact on the temperature because it is wired the wrong way, meaning those electrodes over here could be made out of different materials, and it kind of looks like they are, which is the result, or which results in the wrong temperatures being presented, or the temperatures being slightly off. So this is something that we definitely should fix, which I'm not really looking forward to doing, but I'm gonna have to open it eventually, and since no packages are coming right now, I have some time to actually get that done. But I would very much prefer to spend that time working on the software rather than fixing the machine, especially since so far it seems to be working. I'm getting pretty good results. I got some feedback from a few jobs, and so far no one reported that the socket doesn't work. So at the moment, typically in this business, if the customer doesn't call you, that means everything is good, because they will obviously call you if something doesn't work or there's something wrong. So usually no news is good news. So far no one contacted me informing me that the socket replacement was a failure. So at the moment I'm concluding that we've had 100% success, but we'll wait a little longer. So it does work, so it's not necessarily required at the moment from me to disassemble it and fix the wiring on the thermocouple, but I do have to do it, and unfortunately I have to rewire it both here and there. Or I can just throw away this thermocouple and just rewire it there and just use the other thermocouples. We'll see what route I'm gonna take, but it's not something that I'm looking forward to. Alrighty, so with that, keep in mind that the packages are not coming at the moment. And be aware of that. If you send me something or about to send me something or something is in the mail, it's probably gonna be a week. Thank you guys very much for watching. Thank you for your patience. And I shall see you guys in the next one.